In this video, we will pay a closer attention to the pattern that arises when we expand a binomial raised to a positive integer exponent. Pattern of the binomial expansion of x plus y raised to n. So the binomial we are referring to here is x plus y. So it's not just any other binomial. The expansion is going to be different. Let's say, for example, when your binomial is x squared plus y. That is also a binomial. But when you expand it, the form, the polynomial that will come out is not exactly like the polynomial that we had been discussing. So there's going to be variations along the way. But in general, if the form of your polynomial is something like this, x plus y raised to n, this is how its expansion is going to be. And we will pay attention to the patterns. The expanded polynomial contains n plus 1 terms. So let's say, for example, this one. This one is a degree 4 polynomial. Degree 4 polynomial. How many terms do you have in your polynomial? It's 1, 2, 3, 4, 5. That is 4 plus 1 terms. The power of x begins with n and ends with 0. X to the 0 is 1. So it's written in descending order. So the power of x is written in descending order of degree. So look at this. This one is 4, 3, 2. You have here 1, and then you have here x to the 0, which is just equal to 1. The power of y begins with 0 and ends with n. So it's written in ascending order. So you have here y to the 0, y to the 1, y squared, y cubed, y to the 4th. For each term, the sum of the powers of x and y is n. Look at our general polynomial. N plus 0 is n. N minus 1 plus 1, you have a 1 here, is n. N minus r plus r is n. So here, 3 plus 1 is 4. 2 plus 2 is 4. 1 plus 3 is 4. Coefficients generated by your combination formula are symmetric. When you say symmetric, it means one is the mirror image of the other across a central line or a central point. So here, 1, 1. Look at the coefficients, 4, 4. And, of course, this one will be your midline. Let us answer example 2.33, finding the specific terms of a polynomial. Find the 8th term of the binomial when expanded to the 10th power. 2x minus 1 raised to 10. What is the 8th term? So suppose the 8th term is a sub 8. Look at our first term. Okay, our first term is 10 taken 0. That's the combination formula. And then the quantity 2x raised to 10, 10 minus 0, and then negative 1 to the 0. For the second term, okay, so this is the second term now. The second term, a sub 2, is equal to 10 taken 1. And then 2x raised to 10 minus 1 is 9. And then negative 1 raised to 1. Okay, look at the pattern here. First term, 10 taken 0. Second term, 10 taken 1. 10 taken 1. So for the third term, you have here 10 taken 2. And then so on and so forth. So here, we are looking for the 8th term. So it's going to be 10 taken 7. That's the combination formula for the coefficients. And then 2x raised to 10 minus 7. And then negative 1 raised to 7. Negative 1 raised to 7 is negative. That explains that negative sign. 2 cube x cube. Okay, so 2 cube is 8. X cube is this one. So let us compute for 10 taken 7. Okay, it's supposed to be equal to 120. So 10 taken 7 is 120. So let us now simplify that. Our eighth term is negative 960 times x cubed. Find the fifth term of x minus 5 raised to 7. So our fifth term is 7 taken 4. Okay, so how did this come about? Again, negative 5 raised to 4, that's going to be positive. It's 625. Seven taken 4 is 35. So let us now obtain the product and let us show the fifth term.